The giant swing at the county fair consists of a vertical central shaft with a number of horizontal arms attached at its upper end. Have you ever tried a giant swing before? Not for me. I'm not a big fan of this game, but I bet that a lot of people enjoy it. Okay. So anyway, this is the vertical central shaft here, and it has many horizontal arms. So this is a horizontal arm, so then a lot of people can share, right? There is another one, two, three, four, five, and so on. Yeah, each arm supports a seat suspended from a 5 meter long rod. So this is the rod. And it's like 5 meter long, the upper end of which is fastened to the arm at a point 3 meter from the central shaft. So this is the arm, which is 3 meter long. They ask us to make a free body diagram of the seat, including the person in it. Okay, so they ask us to draw a free body diagram. And what is the free body diagram? Again, we have been discussed a lot about a free body diagram again. So what is a free body diagram? That's just like a diagram free a body, which means that it shouldn't show anybody, nobody. We don't really care about the body now. We just take it as like a mass, like a point mass. And what we need to care is like the forces acting on that body. Why? Because we want to analyze how the forces acting on the body and that can affect the change in motion of the body. So in order to do that, we need to identify that which body we are talking about, then how many forces acting on it, and in order to identify each force, we have to make sure that we know like by which object act on it, direction, magnitude, how strong is the force, and we can express it, we can show it by the length of the arrows, the vector force. The longer the length, the stronger the force. So here, let's see, they're talking about the seat. So where's the seat? Okay, so this is the seat. So which forces acting on the seat? Yes, always. Whenever we have anything on earth, then there should always be a force acting on it. That is the weight, the gravity. So here, that will be from the earth acting on the seat. Direction, yes, downward, right, to the ground. And what is the magnitude? That should be mass, the mass of the body, times with the g, and g is the gravitational because it has to do with gravity, and the nature of it is an acceleration. So g is the gravitational acceleration, which equals to 9.81 meter per second square. Always, that's gravity, that weight acting on any object on the earth. Okay, so now we need to identify other forces. In order to identify that, we need to ask the question. We need to answer the question, which are the body that touches the seat? Which means that they should be in interaction with the seats, right? And let's look around. Who and what? Yes, we see it. That's a lady, right? I hope that she enjoyed the ride. Okay, so actually she's sitting on the seat, right? Oh yeah. And if she sit on the seat, then the seat should also react and then add a force on her, right? But here, let's say we see that she's sitting on the seat this way, and you can if you remember, like usually if you just have the seat normally in horizontal like this, and then you sitting on the seat or the chair like this, right? And then you are sitting still, here. So then think about this. There will be a force from gravity act on you that pulls you down. That will be your mass times with g. And then in order for you to stay still, to stay balanced, then the chair or like the seat should also add a upward force, right? On you, which we usually say that the normal force, which also like perpendicular to the planes here. That is like the seat plane. And then you can stay still when you have these two equals to each other. So actually this is the force that the seat act on the person in this case. But here we are talking about the seat itself. So by the Newton's third law, what does he say? He say that okay. He said that if there's a force at from A on B, so there's also another force that B act on A with equals in magnitude with that force, but in opposite direction. Okay. So if the seat acts on you upward, then you should also like add a force on the seat, but it should be downward. Okay, this is like the force that you, the person, add on the seat, and it should be like downward, and it's the same in magnitude. So in this case, you can see that it's also like perpendicular to the seat plane. So in this case, we can see that the seat is not like in the horizontal plane, but it kind of tilted a little bit like this, right? It tilted a little bit like this. So then, if the seat is acting, actually push the person up, right? And then the person should like push another force on the seat itself, and it should be like downward this way, and it should be perpendicular to this plane of the seat. Okay, so that's the second force that the body act on the seat. What else? Okay, let's just look around here. We see? Yes, so we have the last one, the rod. The rod attached to the seat, and it will pull the seat this way, right? It should be like along this line that makes an angle 30 degree with the vertical, and it should be upward, right? Because if it's not upward, if it's downward this way, then everything will just like fall down to the ground. Yep, so that is the seat. Okay, but let's say, does the question ask that actually is ask a free body diagram of the seat including the person in it. Okay, the person in it. So actually here they care about the whole system. Okay, the whole system here, which include the person and the seat. So in this case, if the whole system here, which is represented as a whole mass with the mass of the person and the seat together as a whole system, then we can see that when we draw the free body diagram, we just want to show the external forces, just the external forces acted on the whole system. So in that case, we don't need to show this force here, right? We don't need to show like the inter force. We just want to show the external forces. So then it could be like much more simplified that we just need the whole thing, the weight here for the combinations. And then we just have the rod that act on the whole thing in this way, right? And then for the F, the between the person acting on the seat or the force that the seat act on the person, we don't need to show. Okay, so actually this is the free body diagram that we need to have, that we need to show. So this is the one. So pay attention to like which they are asking for. And actually they are asking for the free body diagram of the whole thing. Okay, so let me make this one here. This one is actually the free body diagram. Oh, sorry. the free body diagram that they're asking for. This one. Okay, when we included the seat and the person together here, this mass here is the M and the M of the seat and the person on together. Okay,